No.
Okay, good. Today we're going to talk about counting.
Wait, really?
Yeah.
That's like hard though.
So, as I may have mentioned at the beginning of this unit, this is a unit on not just sequences and series, but sequences and series and discrete mathematics. And discrete mathematics includes, well, it's hard to explain what that is actually, but it's anything which involves kind of like, discrete units as opposed to continuous things. Notice that we haven't been talking much about continuous functions lately. We've just been talking about numbers. So proof by induction, for example, is a technique of discrete math. And this is another one, so counting. All right. So let's talk about counting. Some of this, by the way, I should mention, some of this is common sense. Some of this you may have learned already. Some of this, especially if you do a lot of math team and stuff like that, then you know these kinds of things already, and if not, not. Harder first, then you know the better with practice. All right. Let's establish some basics first. So this is just a basic introduction. I like to use examples that were in the kind of math textbook that I read when I was a kid. So, ready? Here we go. This is a story about Sally. Sally has 4 tops, 3 skirts, because everybody back then just wore skirts, and she has 2 pairs of shoes. Question. How many outfits does Sally have? And let's assume that all of her things match nicely, because it's she just wears all black all the time, maybe something like that. So what? Yeah, maybe she's yeah. All right, so how many outfits does she have? So can I get an answer? What's the answer?
24.
Yeah, 24. Why is that? Oh, yeah. Okay, can I get a more words? Yeah, Sam.
There are 4 possible ways, 4 possible tops you could have.
Yeah, okay, good. So Sally is going to choose her outfit, and she's going to choose her outfit in the following manner. First, she will choose a top. I have no idea how people actually choose outfits, men or women, because I just put on all wraps and just hope for the best. But let's suppose that she first chooses a top, and then after that, she has 3 choices of what skirt to wear, and and then finally, choose shoes. So she has 2 choices of shoes. So we can make kind of this Sally decision tree in which each path through the tree represents a different outfit. Does this all make sense? Nod, yeah, yep. And because there are 24 paths through the tree, we say that there are 24 sort of ways for her to do this. All right, so yeah, this goes under the name fundamental principle of counting. Or no, what's this called? Fundamental, yeah.
Counting principle?
Fundamental principle of counting. I think that's what it is called.
Isn't it counting principle?
Yeah, that's right. Fundamental principle of counting. Other people call it the multiplication principle. And the fundamental principle of counting simply says that if there are A ways of doing something and there are B ways of doing some other thing, then there are A, B way, and those things are independent of each other, then there must be A, B ways of doing each of those 2 things. Do I have to write that down? I don't feel like it. Okay, good.
Just do it.
Oh yeah, I wrote it right here on my paper. If there are A ways of doing thing 1, and independently B ways of doing thing 2, then there are A, B ways of doing both. Alright, this is basically all you need to solve a whole category of problems. For example, how many 7-digit license plates are there? 7-digit license plates. License C? No, S-E? S-E. Is that right?
The letters and numbers.
I don't know how to spell the word license. But how many 7-digit? Okay, so we're going to assume that there are 7 characters and they could either be alpha or numeric.
There's only capital, right? There's only capital, right?
What?
Only capital letters.
Only capital letters? Yeah. And then that's America. So basically, how many choices do we have for the first? How many choices do we have for the first number?
36.
Yeah, we have 36 choices because, barring any kind of special laws or anything, probably you can't have a license plate that says screw you or something like that. They probably won't let you do that.
They won't.
They won't, right? You tried? Okay, so yeah, there are 36, there are, ignoring that kind of issue, there are 36 choices for my first character, right? Because there are 26, nod, do with me, 26 of them, yeah, mm-hmm. And then the second, how about the second character in the string?
36.
Still 36, right? Because the choices of each character are independent of each other. And so we have 1, 2, 3, 4, 5, 6, 7. For each of those 7 characters, there are 36 possibilities, 1 for each letter, 1 for each number. And so the answer to this problem is like big, right? A lot. 36 to the 7th power. Cool? Say cool.
Cool.
Okay. How many, okay, that's pretty much fine, right? Let's ask a more exciting question. How many 4-character strings can you make out of the letters in the word sequoia?
But how do you spell that word?
Well, I'm glad you asked. It is an exciting word because it is the shortest word of English, which has all 5 vowels in it. Sequoia. It's a kind of tree, I guess. Maybe a
redwood is a sequoia, not the other way around.
Whoa. We got a tree expert here. Yes, what?
First 4 letters with the word sequence.
What?
It shares the first 4
That's
letters
true.
with the word sequence.
What?
It shares the first 4 letters with the word sequence.
Everyone keeps talking during his first word, and I can't hear what he's saying.
Says it shares the first 4 letters of the word sequence.
It shares the first. Oh, yeah. Who cares? No. Okay, good. All right. How many 4-letter strings can it make out of this? Well, how many choices do I have for the first string? 7. Oh, by the way, you need to ask a clarifying question. Otherwise, like,
Can
we're
you
not sure
repeat
what's going
letters?
on. Yeah, can you repeat? So let's do it with repeats. If you do it with repeats, it's kind of boring, right? 7 choices for the first character. How many choices for the second character?
7.
Also 7. And so, by the fundamental principle of counting, since all these choices are independent of each other, the answer is just 7 to the 4th. Alright, what if you're not allowed repeats now? Like if it's like, magnet poetry, one of those things where like,
Wait, hold
not
on.
magnet program, like magnets like on your fridge.
Arlo.
You know what I'm talking about?
Arlo.
That was really popular in the 90s.
Arlo.
So suppose we just have these letters and you need to like arrange them, right? Like you had like, anybody know what I'm talking about at all?
Yeah.
Good, alright. How many choices do you have for the first character? 7. How many choices do you have for the second character? And then, yeah. Good. So whatever that number turns out to be. Alright, alright, so there are many problems which you can solve by just the fundamental principle of counting. One particular kind of problem which comes up over and over again are these things called permutations. So a permutation of a bunch of a set of numbers or a set of objects is a way of arranging them all. Can you like move so like this is like the left edge now?
Yeah.
Alright, so, yeah. So, let's do it. So suppose I have some set, and the set is just the letters A, B, C, D. A permutation of A, B, C, D is just some way of ordering the elements of this set. How many permutations are there? How many permutations are there?
4 to
Seems to just be a lot, right? It seems to be a lot. What we're going to do? One permutation is like A, B, C, D. Another one would be like, A, B, D, C. Another one would be like A, C, B, D, and like A, C, D, B. Okay, this would be like kind of annoying to list them out all, but you could. The better thing to do would be to sort of be systematic about it, right? If I need to permute all 4 of these of the elements of the set, then what I'm really doing is I'm coming up with like a string, right? Yeah. And how many choices are there for the first element in the string? 4. And thus how many left for the second? 3, 2. So the answer is 4 factorial. Okay, so I think this kind of makes sense, right? If there are n, if you have a set of n objects, then there are n factorial different permutations of these objects. Different permutations of these objects. So if there are like 25 people in this class or whatever today, and I wanted to put you guys all in some kind of order, there are a really lot of different ways of doing that. And you pick someone to be first, there are 25 choices. Then you pick someone to be second, there are 24 choices. So the answer is you get 25 factorial, which is like a gigantic number. Okay, I think that makes sense. Does that make sense? Yeah. Yeah, good. All right, let's take it up a notch. So all right, we go to the flip to the backboard. what I want to talk about now is a kind of thing. Okay. So we're going to tell a little story. Suppose, someone just hung up their jacket. How cute. Okay. So let's suppose that you have 7 classes, and let's suppose that for each of those 7 classes you have a textbook, and you keep your textbooks at home, all up on the shelf, kind of nice. So you have 7 textbooks for 7 classes. 7 textbooks for 7 classes. Yeah. So you have I can just draw the books up on the shelf, 3, 4, 5, 6, 7. So you have textbooks like A, B, C, D, E, F, G. Textbook A is for algebra. Textbook B is for biology. You can be more creative if you want. Textbook C is for
Chess.
That would be a weird class, yeah. Chess, chemistry, what the other ones? Someone else said something else.
Comp
Comp sci, yeah, calculus, okay. D is for
Dance class.
dance class?
I didn't say that.
Discrete math, maybe
And algebra, you're taking that in.
dinosaurs? Whoa, that's another exciting class. E is for
Economics.
entomology, economics, I don't know what else.
Extinction.
Earth science, yeah, good. F, forensics,
Function.
I don't know, French, maybe something like that. Flowers? Oh, that's another fun. This is a great high school. And G is for?
Geology.
Oh yeah, could be anything, right? Geography or maybe I don't know, German or something like that. All right. Good. Okay, so here is the plan. The plan is you have, let's suppose this is not a block school, but one in which you have every class every day. And so you have a bunch of homework to do every night. You have homework in every single class, and in every single class, it's in the textbook. So you go home and you just kind of sit down at your desk and you're like, oh man, I have a lot of homework to do. I have to do 7 different pieces of homework. And let's suppose you sit down and you make a plan each day about which homework you're going to do it in what order. Calvin, this is what responsible people do, I guess. I don't know anyone like this. But they sit down and they make a plan. I'm going to go home and sit down, I'm going to make a grilled cheese sandwich, I'm going to do this homework, then I'm going to do this homework, then I'm going to do this homework, I'm going to take a break, and then I'm going to eat dinner, and then I'm going to do this. Okay, so how many different ways, and it kind of matters which homework you do first, right? You don't want to save math to the end, right? Yeah, then you're all tired and stuff, and whatever. Maybe you don't get to it. So you're going to kind of put the ones at the end that you think maybe the teacher won't collect the homework, or who knows, So, how many different ways are there to do your homework? Whereas I count different if you do it in a different order. 7 factorial, right? That's kind of what we just talked about a minute ago. There are 7 factorial ways of doing your homework. And maybe I'll even just start listing some of those ways, right? Here's what.
You can't list all of them.
I can't list all of them, but let me just do a couple just to get a sense of it. Suppose I decide that I really want to do what did we say it was? Algebra, and then chemistry, and then French, and then English, and then I might do biology, and then German, and then what's D again?
Discrete math.
Dance. So that's one possibility. Or I might instead do algebra, chemistry, French, English, and then we'll just go. Let me just go B, D, G, and then maybe F, E, and then maybe that's just D, B, G. This is a riveting video. For those of you watching at home, who knows what I'm going to do next? D, G, B. There's a point to this though. Hang on. 2 more. And I could just do what I want to do next? Oh yeah, G, B, D, and then G, G, B. Okay, so this is just a tiny. What happens? Oh man. So this is just a tiny sample of the giant number 7 factorial, right? Because this is just all the ways of doing the last 3, but there are this all assumes that I go do A, C, F, and E first, Okay. So this is gonna be a really long list. All right, good. All right, so this is what you hope for. Calvin, this is what people do. People are like, man, I'm gonna go home and I'm gonna just do all my homework. It's gonna be great. All right, now let's talk about what really happens. What really happens is you plan out that you're gonna do all your homework, but then you get home and then you like get a snack and then you like sit around and then you like take a nap, you watch some TV, then it's like dinner, and then you like play some video games. I don't know what you guys do. I don't know, just like maybe you like actually like have to play sport or something so you don't get home till late. And then like next thing you know, Twitter, more video games, talking on the phone. Now it's like 10 o'clock, and you haven't done one single thing. Alright, so now we have to amend the plan. There's no longer time to actually do all 7 homeworks, right? So now we have to go into damage control. So the damage control, we need to update our plan. Now we're just going to do 4 of them. So we're going to say, like, alright, look, I don't have time to do all 7 classes, I'm just going to do 4 of them. How many ways are there to just do 4 of the subjects? So now it matters, obviously, which 4 I do, but it also matters in which order I do them in. Well, let's think it out, right? This is kind of like the problems we've been doing. If I'm going to decide, man, there's only time to do 4 classes, I'm going to make a new revised plan now. How many ways are there to choose which to do first?
7.
Right, I have 7 choices of which to do first. And how many ways to do, now 6 times 5 times 4, right? So whatever that number is, 840? He says it's 840. I don't know if he's right or not. But he's 20, 14, yeah, that's right. So this is the number of ways of doing just 4 of them. Okay, so do you see some kind of like pattern going on here or something?
Yeah.
Yeah, those of you, especially if you've seen this formula before, maybe. What is this number, 7 times 6 times 5 times 4?
7 factorial divided by 5 factorial.
Yes, this is kind of like a factorial. So it's like 7 times 6 times 5 times 4 times 3 times 2 times 1. But then I want to like cut it off at 4, right? Yeah. So therefore what I'm going to do is I'm actually going to divide through by 3 times 2 times 1. And that gives me this thing which intuitively seems like the correct answer. Everybody with me? Okay, so if you have seen this before, the answer then is just, yeah, it's just 7 factorial divided by 3 factorial. And if you think about it, where did that come from? That came from, well, okay, so how about we just do this like in general now? Suppose I have, what I want is the number of ways, so this is the kind of conclusion that we're coming to right now. The number of ways of permuting k objects from a set of n objects. So the number of ways of permuting k objects from a set of n objects is, and there's a symbol for this. The symbol we say is NPK. And the N refers to the fact that there are N objects in total. In this case, the total number of objects is the 7 textbooks. And K refers to the number of objects I'm going to choose. In this case, K is 4, right? Everybody with me? And what I'm doing is, if I have a total of N objects, I would like to choose from amongst those N, K of them, and like permute them, right? So the number of permutations of size K drawn from a set of N is, can someone give me the formula, just generalizing from this special case?
N factorial over N minus K factorial.
Yeah, N factorial divided by, notice that there are 4 books here, but I'm dividing by 3. What I'm dividing by is N minus K. Okay, so this is a very interesting formula, and in fact what I would like us to do is understand this on kind of a little bit of a deeper level than what's normally presented. I think this kind of makes sense, but let's talk about it a little bit more deeply. The answer to this, the number of ways of doing this is n factorial divided by n minus k factorial. Okay, well, so there were 2 separate problems here, right? The original problem was how many ways are there of doing all 7 pieces of homework, and the answer to that was 7 factorial. And then I divided by 7 minus 4 factorial. Well, why did I do that? If you think about what's going on here, is this was my list of all the plans of all the things I intended to do. But then we decided that there's not time anymore to do 3 of the subjects. And so it's as if you took your old plan and you just like cut it off after 4, right? If you cut it off after 4, then what's left is all the things that were going to happen, but have now been, we've now decided like those are just being, that plan's being like abandoned, right? So like, for example, over here, one of my plans was to do A, then C, then F, then E, then B, then G, then D. A different plan I had initially, when I was riding home on the bus and I was like full of high spirits, I was gonna maybe another idea was to do A, C, F, E, B, D, G, etc., etc. But now, what can I say about these 6 options?
They're all the same.
They're all the same now, right? What I have essentially done, when I've decided that I only have time to do 4 of the subjects, what I've essentially done is I've taken my old list, I've cut off the last 3, and then what happens with this old list is that these 6 options, which previously were considered to be 6 separate and independent plans, are now actually just the same plan, right? And therefore, what I realized when I'm trying to solve this new problem, if I only have time to do 4 homeworks, what I have is, if I look at my old list is precisely 6 times too long, right? Why 6 times too long?
Because there's 6 of those for each.
Because there are 6, also known as 3 factorial, ways of permuting the subjects that I didn't do. So if this total is 7, this is the number k, which in this case was 4. This is the leftover ones, n minus k. If I have n objects, and I want to know how many ways of permuting k of them, one way to think about it is, you take all the ways of permuting all n of them, of which case there are n factorial. And then you divide by n minus k factorial, because n minus k factorial is the factor by which your list is too long. It's too long by that factor because for every one of the things that never happens, you can put them all and you can arrange them in n minus k factorial ways. Is this a good explanation? You guys feel like you get this? Yeah. Are they cool? That'd be cool? Okay, good. Alright, so that's like that. Alright, next thing. Yeah. Okay, now, similar kind of story. Griffin, please move the camera if necessary. Similar kind of story, but now, so I still have my 7 textbooks, but now, I don't even care, like, 3, 4, 5. I don't even care what order I do the classes in. At this point, it's like 10 o'clock. No, let's up the stakes. It's 11 o'clock, 11:30. Say it's 11:30. And what I want to do now is, I just meant like, man, I need to do 4, I need to just get 4 of these done, and I need to just go to sleep. So, now I'm asking a different question, which is how many ways are there of choosing which 4 I'm going to do? I don't care about the order anymore. The order is no longer important. And so, what I want to do now, so basically what I'm asking is, how many ways are there of choosing, how many ways are there of choosing choosing k objects from a set of n objects? This is kind of similar to the previous question, but now the order is now irrelevant to me, right? So you think of it, in this case, what I want to know, and there's a symbol for this, it is 7, choose 4. This is what lame people do, like our textbook, but cool people do it like this. And this is pronounced 7, choose 4. And 7, choose 4 is supposed to represent the number of ways, given 7 objects, of picking 4 of them. So think about it as a simultaneous choice. Okay, I'm walking up to my shelf, and I'm just going, all right, I'm just going to grab 4 of these 7 textbooks, right? I could just take like A, C, E, and G, and just grab them, right? Never mind which order I'm going to do the homework in, just how many ways are there picking which 4. Okay, so let's talk about this. So what do you have to say? Well, you probably like know this and stuff already, but do you have something to say?
Oh, I also just
You also just like know this. Well, let's talk about it. I don't know, does anyone have something to say? Or maybe it's just clear? I'm just going to call him Daniel Chen, because you know this too. Daniel Chen, talk to me.
It's like similar to that, but like you don't care about the order now. So,
Yeah.
So you need to find some way of consolidating all of those like different arrangements into one.
Yeah.
I mean, kind of.
Yeah, so now the list is like too long in multiple ways, right? Because now what's going on is, so I want to know what 7 choose 4 is, right? Well, what I can do is I can take the full list, which was 7 factorial, right? And then I'm going to divide by 7 minus 4 factorial because I'm only going to do 4 of them. But now look, this list is still too long, right? Because it's like there's going to be, well, okay, let's just suppose what I choose is actually these 4, this ACFE. How many ways, how many times does ACFE appear on the list? Well, a lot of times, right? Because I can go ACEF, but I could also go ACFE, and I could also go AECF, and I could also go AEFC. And then how many ways are there? How many ways are there of me doing those 4 particular subjects? Yeah, there are going to be 4 factorial ways. 4 factorial ways for me to with different orders, which all result in the same thing, which is that I do A, C, E, and F. And so in other words, I need to take the old list, the list which we already decided was NP4, and I need to further divide it, right? And I need to divide it by 4 factorial. In other words, I took the long list, which was 7 factorial. If all I care about is how many ways are there of permuting 4 of them, then I divide by n minus k, because the subjects that never happen, I don't care what order they're in. But then I also don't care what order A, C, F, and E are in. So this list is still going to be 4 factorial times too long. Is this making sense? I feel like I've explained this decently well, but maybe. Okay. So, yeah. So the general formula for this turns out to be 7 factorial over 4 factorial, 3 factorial. And in general, are you moving the camera?
Yeah, I have been.
Okay, in general, n choose k.
Yeah, that's good.
In general, n choose k is going to be npk, the number of ways of permuting k objects, and then I further divide through by k factorial. Because in all those different permutations of k objects, I now no longer care in what order they're in. So I divide through by k factorial because this list is too long by a factor of k factorial. And so this is just n factorial over n minus k factorial over k factorial, otherwise known as n factorial over n minus k factorial k factorial. This is the number of ways of choosing k objects with a set of n. Raise your hand if you've like seen this formula, you've seen these formulas before, like in middle school or like math team or just like blah 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 blah. Okay, cool. All right, good. That's it. Hopefully that teaches you counting. I went a little bit slower than I probably would have.